All right, so today we are doing a quick mini lesson kind of talking about domain and range. And specifically, we're going to want to be able to describe the domain and range based on graphs. First off, let's make some quick definitions. So domain is going to be all possible inputs for a function. And let's kind of remember that inputs, those are going to be our x values, right? That's what we plug into the function, and that's going to be our x-axis. And our range is just going to be all the possible outputs for a function. These are either going to be what we call our y values or our f of x values, right? We kind of use that similar notation, y or our function notation, describe our output. One final thing to remember before diving into our example problems is that we are only going to have one output for every input. What this means is that no vertical line should cross our curve more than once. We touched on this before. I want to kind of spiral it in again. And the reason we're kind of covering domain and range today is to make sure that we have a good understanding before our next unit, where this is going to be talked about a little bit more. And it also came up on our middle of year benchmark, and I want to make sure we address it more formally than we've talked about in the past. So, looking at example problems for each graph, we're going to describe the domain and the range, and then we're going to identify whether or not it is a function. So, starting with example one, let me lower this a little bit. Remember, if I'm looking at my domain, I'm concerned about our x values. So if I look at graph one, it looks like the only x value that happens on the left is at -3, and the only x value that happens on the right is at +2. So I can say that my domain for graph one is x equals -3 and x equals +2. Those are the only possible x values on my graph. The range, however, if we look at this, it starts at this +2 here and goes down forever. That's what that arrow means, right? And then it starts at this +2 and it goes up forever. So if I think about this, the entirety of all of my y values are covered, so I can write in all real numbers here. All real numbers are covered in that range. Lastly, if we want to think about whether or not this is a function, there is no vertical line that would cross our graph more than once. This might be difficult to see on this one. It'll make more sense on some of the future ones. So this is a function here. Cool. So moving on to number 2, and I'll kind of clear off some of these notes to make my screen a little less messy. We're looking at our domain. So we have this graph here. It looks like it kind of roughly starts at this point and ends at this point, and we got a straight line that kind of connects all of these spots, and it's continuous. But notice here we have an open circle over at the left at -5. We have a closed circle at the right at +5. So that's going to impact kind of how we write our domain. Our x value we know is going to go all the way from -5 to +5, because that's kind of the bound that's set on our graph here. If we look at that, notice how it's in between -5 and 5. We've dealt with this inequality notation before. The thing we want to account for is, hey, on the left here we have an open circle. On the right here we have this closed circle, so we're going to want to include +5 in that domain. Notice how this traps, there is no x value that goes beyond that point. And then if we want to look at our y values here, okay, we can kind of write a similar notation to describe what our y values are. Our lowest y value looks like it's at 2, right? Our graph reaches 2, and down here it reaches 2 as well. So 2 is going to be less than y, or sorry, -2, my apologies. And then our graph tops out at this +2 here at that max line, so it'll max out at +2. Lastly, if we want to look to see if this is a function, I can draw a vertical line at any point on this graph, and I can see that, hey, it is only crossing once. So that means that, yes, this is a function here. for this graph. And you do not need to draw all those vertical lines. In fact, your notes are going to look really messy if you do. All right, we're going to do two more before I kind of let you work on your own. This last one, first thing I want to note is that we have these arrows here, all right? And these are not straight lines, they're slightly curved. So what this means is that I'm going to go forever to the left and forever down. And on the right, I'm going to go forever to the right and forever up. So what that means is for both the domain and the range, since this is a continuous curve, it doesn't have any breaking points in it, both of these are going to be all real numbers. All real numbers. Sorry about that bell for those of you that were listening on high volume. Okay, and then if we run that vertical line test to see if this is a function, we can kind of trace any vertical line here. And we see that, hey, our graph is only getting crossed once by that vertical line. So this is indeed a function. All right, last one here, problem 4. This is the last one we're going to do as a group. I'm going to ask you guys to do the rest on your own and check the answer key. We have a circle. And if we look at our circle, our x values go all the way from this -2 to +2. See that we're kind of bounded there. And my y values go from this +1 all the way up to +5. So this will kind of dictate what our domain and range are. And in both of these are inclusive because that line's hitting that point. So I go -2 is less than or equal to x is less than or equal to +2. That covers the left bound and the right bound. And then my range, 1 is the minimum, so 1 is less than or equal to y is less than or equal to +5. That covers my lower bound here and my upper bound here. If you wanted to, you could also write this as 1 is less than or equal to f of x is less than or equal to 5, if you want. That's just a different notation describing our output. Finally, dealing with whether or not this is a function, if I draw a line through this circle that's straight, you're going to notice that, hey, it crosses at 2 different points here and here. And that happens basically throughout the circle except for the edge there where it would just cross once. So in this case, it is not a function. We cross more than one spot. So take the rest of the time. I know there's a playlist that you're trying to work through in class, but make sure you can hit 5, 6, 7, 8, 9, 10, 11, 12. There's some tricky ones in there, so make sure you're checking your answer key as you go and just getting a good understanding of this domain and range before we start our next unit.